All right, hello again, Ling statisticians. We're still working our way through the basics here, and today the basic that I want to talk about are measures of spread, or is measures of spread. So this should be a relatively short one because we're only going to cover two different measures of spread, but we're also going to see how they kind of relate to other things you can do in R by the time we're done with the mini lecture. So what have we learned so far? Let's get back into the swing of things. We've talked at some length about distributions, which are an arrangement of statistical data that exhibits the frequency of occurrence of the values of a variable. Hopefully that idea is familiar by now. And distributions, which are these arrangements of data, have different properties, including, say, measures of central tendency, like the mean, the median, and the mode. We also found out that you can take a look at what distributions look like, what their shape is, by plotting a histogram. And that, in fact, there are a few common distribution shapes, which we see fairly often, like normal distributions or, say, bimodal distributions, J-shaped distributions, so on and so forth. So yeah, those are two important properties of distributions already. And then the last one that we're going to talk about today is measures of spread. Okay, so what do I mean by measures of spread? The first one we'll take a look at with respect to the Stevens-Svetlana p-pod data. And in order to help us do this a little more efficiently, again, I still got the clock going here. It's 2:30 on a warm Monday afternoon in June. I've ordered the data from smallest to largest for both Stevens-Svetlana's p-pods from back in the day. So we have 12 items in each sample, and Steve's ranges from 6 to 8, from 6 at the bottom end, 8 at the high end. Svetlana's ranges from 4 at the bottom end to 9 at the high end. And in fact, that is specific, the exact measure that I want to talk about. So I've actually given away the sort of answer here by calling it the first basic range measure. That's not right. I should fix that and say measure of spread, because the name of the measure of spread is the range. Yeah, and that might make the formatting here a little awkward, but we'll try to fix that. Okay, no problem. And it's just what I said there a second ago. It's the simplest thing you can think of, basically. Let's go from the low end to the high end and see how many different what's the difference between the high and the low end in terms of the actual value of the variable, and that's my range. So yeah, it's the difference between the smallest and the largest value in a sample. For Svetlana's p-pods, we're going from 9 at the high end to 4, so the actual range is 5. You can think of it as it ranges from 4 to 9, but if you spit out like a specific value for range, like in R, it'll give you 5. And then for Steve, that ranges from 8 to 6, or 6 to 8, and that's a difference of 2. So that's pretty straightforward, just minimum versus maximum, or maximum minus the minimum for range. Measure of spread number 2 is also a range. It's called the Inter-Quartile range, and that reflects the difference between the first and third quartiles of a distribution. Excuse me for a second. Yeah, so range in general is, like I said, fairly simple, but also maybe not that super informative about what's going on inside the distribution. This is a way, the interquartile range is a way to take a look at more of what's going on inside the distribution by calculating these values known as the first quartile and the third quartile. So what is a quartile? The name might kind of give it away a bit because the word quart is in there, or you can think of it as like the quarter aisle. I guess we're going to split the distribution up into quarters and then kind of figure out where we are at each quarter in the distribution. So a quartile is going to be defined like the median of a distribution, which we saw a couple lectures ago, except that they only apply to either the bottom or the top half of the distribution. So you split the distribution up in half to begin with, and then you split each half up into halves as well. The bottom half of the distribution, like the lower valued numbers in the distribution, I'm going to call the bottom half of the distribution, and the first quartile will be in the median of that half of the distribution, and the third quartile will be sort of the median of the top half of the distribution, or the higher valued items in a distribution. And I guess you could think of this as well, like the median as, say, the second quartile, if you really want to. People don't normally talk about it that way, but that might give you a sense of how this is progressing between first, second, the median, and third quartile of the distribution. And then like the fourth quartile and the 0th quartile will be just the edges we've seen in the range, like on the previous slide. Yeah. So more to the point, though, the first quartile is the median of the bottom half of the distribution. The third quartile is the median of the top half of the distribution. And the interquartile range is just, the difference between those two quartile values. So this might make a lot more sense, or hopefully will make more sense, if we take a look at another example for it. So let's go back to the Peapod data. We've seen this enough times now. But we've got this ranging for Steve from 6 to 8, for Svetlana from 4 to 9. And so the first thing we need to do to calculate the quartiles is split the whole thing up into two halves, like right there. So now we've got these 6 values on sort of the low end, and then these 6 values on the high end of the distribution. Conveniently, this one has an even number of values, so it's 12 total, so we can evenly split it up. That made us do some extra math for the calculation of the median before. It's going to make us do a little extra math for the calculation of the quartiles as well, but in the long run, it's kind of a little bit simpler to do it this way. So we're first splitting up the distribution here in half. Now I want to take a look at this half and just say calculate the median of this one as if it were just by itself, and that's going to be the first quartile. So I'm going to split this one in half as well between the third and the fourth values. And so for Svetlana's data, I'm going to take the average of 7 and 8 because those are the two values in the middle. And the average of those two, or the mean of those two, is 7.5. And then for Steve's data, well, I'm just doing Svetlana's in this one. But for Svetlana's third quartile, I'm looking at the median of this bottom half, or sorry, it's lower in the on the slide itself. I've been calling it the top half of the distribution, but just basically looking at these 6 numbers by themselves, what's the median of these values for Svetlana? And it's 8, right? It's the mean or average of 8 and 8. Correspondingly, if I do the same thing for Steve's data, what I get is the first quartile equal to 6, because those are the two values in the middle of this half of the distribution. And then down here, I have to do very little arithmetic work. 7 and 8, the average of those two is 7.5. And I kind of glossed over this on the previous slide, but if you take 7.5 minus 6, that range is 1.5. Before, I had a first quartile value for Svetlana of 7.5, and then the third quartile was 8. So 8 minus 7.5 is 0.5, right? That's not too hard to figure out, I don't think. So that's, again, basic arithmetic. But, it may be worth noting that the interquartile range is a bit bigger for my batch of Peapods than it is for Svetlana's Peapods. That doesn't really mean anything. It just, there it is. I will also point out, I haven't actually made this explicit, but I'm talking about the interquartile range, and it's often going to be abbreviated IQR, just so you know what that means. And I will point out a couple of things here. One is that if we take a look at the range versus the interquartile range, we see some interesting differences between the two distributions here. So Svetlana's range was larger than Steve's range, 5 versus 2, because we were looking at sort of the extreme values there. But the interquartile range for Svetlana was smaller than Steve's. So it was only 0.5 versus Steve's, which was 1.5. So there's sort of more variation at the extremes for Svetlana than there is within the distribution itself. And then the opposite of that is true for Steve, because these two measures are almost the same, 2 versus 1.5. And then we get a kind of switch in which one is bigger between the two distributions. So this kind of corresponds to what I was talking about before with comparisons between like the median and the mean of a distribution. So the mean of a distribution is more sensitive to extreme values than the median is. And this tendency is going to be even more exaggerated for the range versus, say, the interquartile range. And hopefully that's obvious, because with the range, you're looking precisely at those extreme values at the edges of the distribution. So you're going to incorporate those into your the calculation of that value specifically, or explicitly as well. But the interquartile range is going to be a little more balanced. It's not necessarily going to reflect those extreme values. It's going to reflect kind of what you can normally expect to see on either half of the distribution. So like the median, the quartiles provide a more stable representation of the central tendencies on either side of the distribution. The IQR, or interquartile range, thus provides a more reliable picture of the variability within a distribution than the range. what I'm working up to here after this lecture. The next lecture, we're going to look at a way of portraying data in a distribution called box plot. We're going to kind of wind up incorporating both of these measures in it in different ways. But this is sort of why the interquartile range takes a more sort of prominent role in the way that people present data nowadays. It's kind of fun to look at like extreme values often, but they're not as meaningful. So people focus on sort of what is more representative of the entire distribution when they're trying to present what their data look like. And these are things that you should definitely look at yourself. You always want to take a look at your data to get a sense of what's going on in it. And that's why it's good to know about these different measures of spread for a distribution, among other reasons. So I will also note another thing, which is that there's an open question as to how to calculate the first and third quartiles when the entire distribution has an odd number of values. So the examples we've been playing around with have had 12 different items in each sample, right? Give you a second. So what do you do when you don't have 12 or some even number, but rather have an odd number of values, like say 13? You add one more in there. Let's say, well, I'll give you an example in a second, but if we selected another peapod each, that means that we can't really evenly split up the distribution in half, right? There's 13 total that divides into 6.5. Do you divide the distributions up into like 6 each on both halves and then leave the middle value there doing nothing? Or do you include that seventh value within both halves? It's a little bit weird, right? Because if you just take one half, like 6 on each side, and don't include that median value is providing you some information. You should probably include it in the calculation somehow. But then if you do, like, how do you assign it to one half or the other? Or do you include it in both halves? So it turns out there's no easy answer to this question. And apparently statisticians themselves, the real ones, are split on whether to include the median in each half of the distribution when calculating the quartile values. So it turns out you can do this either way, and the choice is up to you. But if you do include that median value in the calculation of your quartile values, then you have to include it in both halves, basically. So in that case, if I had 13, I'd be taking items 1 through 7 for the top half, and then items 7 through 13 on the bottom half, right? But if you don't, then you have to exclude it in both, right? So you go items 1 through 6 for the top half, or 8 through 13 on the bottom half. And I'm just realizing that I'm switching the way I'm expressing top and bottom halves, and I'm sorry about that. But hopefully you can figure out that there's just two halves, and there's just an open question about what to do with that middle value. Yeah, and so this is the rule of thumb, again, that I just said out loud rather than showing it to you. But basically, again, the choice is up to you in terms of how you do it. So that's all I'm going to say about that for now, because I think I've said enough. But what do we know by now about all these different measures of central tendency and spread and so on and so forth for this randomly interesting selection of peapod data from 8 years ago for two different people that you don't maybe even really know. So anyways, here's the mean and the median for both of our distributions, the mode. These are the three measures of central tendency right off the bat. You can also talk about the minimum and maximum values, which figure into the range of each distribution. And then there's the first and third quartiles, and then we take the difference between those two and we get a measure of the interquartile range. So these kind of go together in terms of threes or sets of threes. These are the central tendency measures. These are the range measures here. And then these are the interquartile range measures down at the bottom. And you see they all kind of look a little bit different from one another and tell you slightly different stories about what's inside the data itself or what's inside the distribution. So normally when people report, say, the basic stats for their, or basic, numbers for the data they've collected, they don't just give you like one number like the mean, because that will only tell you so much. So one way to report what's inside your data is to combine them into what's called a 5-number summary. So this will tell you 5 basic numbers about your distribution of data. At the low end, it gives you the minimum, then it gives you the first quartile, then the median, then the third quartile, and then the maximum. So if you remember, I kind of talked about like thinking of the median as like the second quartile. You can kind of think about this as like going from the 0th quartile to the first quartile to the second to the third to the fourth quartile. If you want to split it up like that, you're just getting, you know, these measures of extreme values on the edge as well. And then what's nice about this is you don't have to explicitly report what the range is or what the interquartile range is, because you kind of get that information anyways just by reporting the numbers that go into that calculation for both. Yeah, so I'll give you the 5 number summaries for these 2 data sets. And we've seen these already, but this kind of gives you a sense of what it would look like if you were to use sort of a similar command to calculate this batch of data in R. And you can see when you look at it this way that the Steve data, I guess I'll call it, is a little more tightly packed towards the middle, especially because of these extreme values being, almost identical to the first and the third quartiles. For Svetlana, you get more of that effect of the extreme values on the edges. And I'm not going to say much more about that, but it just gives you more of an overall picture of what's going on in the data. And I made this point before that you don't need to explicitly say what the range and interquartile range is if you do it this way, because you can figure that out by taking just one more step after seeing these numbers. Okay, lastly, I'm going to point out that there's a simple command for calculating a 5 number summary in R. And this is actually the point where I'm going to go switch over to R briefly. I want to walk you through how to use a whole range of commands that we've talked about in R. Not in this video, or not even in the next video where we'll talk about box plots, but I think in a couple of videos we'll just walk you through how to play around with all this stuff, just to give us a sense of how R works, basically. But I'm going to get us started at least this way by showing you one thing which I think I've shown you before, which is how to kind of put data into the R system. Maybe I can make this a little bit bigger so you can see it. But this is Svetlana's data, which I'm just copying and pasting from these basic R commands that I've got up on the course website. So we've got these data points in these 2 different vectors, they're called. My machine is overheating here a little bit because it's hot today. Hopefully that isn't messing up the audio too much. But what I just want to show you is there's 2 different ways kind of to look at the 5 number summaries. So if I just say 5 num and then put Svetlana in parentheses, this gives me that information I just showed you on the previous slide, the one right here, right? Hopefully you can see that that matches up pretty well. And then there's also a similar command you can input for the Steve data, and that matches up well there as well. There's another similar command called the Summari command, which actually is one we'll probably use fairly often. And what this adds to the mix is the mean as well as the median. So I'll show you what it looks like when you get the output. It's also a little bit nicer because it tells you what these numbers are actually representing. Minimum, first quartile, median, mean, third quartile, and max. So it's same sort of spread across the distribution, right? The tricky part of this, which is actually kind of annoying, is that it calculates the quartiles in a slightly different manner. So you think it should match up to what we see here, but it gives you a slightly different number here for Svetlana, going from 7.5 to 7.75. Yeah, why did it do that? And then we can look at the same numbers for Steve's data, and then we'll see that it does something also slightly different for the third quartile, going from 7.5 to 7.25. Yeah, there are reasons why this is so, and it took me a while to kind of pin down what was going on here. I looked for it because I was a little bit annoyed by it, but also because students would ask questions about it. I'm not going to take the time to answer it in this video. I'm just going to let you know that it's there, so be on the lookout for it. And I'm going to post what's going on in a separate batch of notes on the course website in case you're really curious and want to figure it out. But I will tell you one way to kind of fix it. So if we look at this IQR command, which is interquartile range, and apply it to Svetlana's data, it gives me that interquartile range based on the way it's calculated here for the summaries. 8 minus 7.75 is 0.25. And the way to fix it is to say explicitly tell R to use the second way of calculating the interquartile ranges, which is the 5 num summary or command way of calculating it. So it should spit out 0.5 here, which is kind of what we'd expect based on what I've told you. That's the way to fix it. R can do a variety of different things, and it's just kind of not coordinating with itself in terms of how it's calculating interquartile ranges or the quartile numbers themselves between these two commands. But you can make it better if you really want to. You can do all sorts of different things with R, and the power is there. You just need to know sort of which commands to use to make it happen. And the same sort of correction applies here to Steve's data, in case you were worried about that at all. Okay, so that I recapitulated everything that's already on the slide. I don't need to really say it again. That's all I'm going to do with R for today. Next time, I want to walk you through how to calculate box plots, though, and also to how to create them in R and see what they look like. So we get kind of a graphical representation of what is going inside of our data. So we can look forward to that as well. And then there's also going to be one or a couple more measures of spread, which are usually regarded as more important or people think about more often in stats than these particular measures of spread. They're called variance and standard deviation. We'll talk about those after box plots. So we have a lot to look forward to, as I'm sure you know. So I'm going to stop this for now, and hopefully this is reasonably short enough, 20 minutes. Okay, see you next time.